Okay, so in this video, we're going to look at another application of data frames, in this case for population analysis. So this is the CSV file we're going to look at. This is taken from Wikipedia. It has about, so basically it has for each country, the population measured at in July, on July 21st, 2018 and July 1st, 2019, and the change in percentage, whether it's an increase or decrease in the population during that 1 year. And the file also includes the continent to which the country belongs to, as well as some continents have more than one region. Most of the continents have more than one region. Like Asia has Eastern Asia, Southern Asia, and so on. So we'll also list the region within that continent the country falls under. So this CSV file has about 233 records. The first row is basically the country, the column names, column titles. Uh, so we are going to read this CSV file into a data frame. So we'll use this syntax to read the CSV file, CSV dot file, and then the file name, CSV file name. So the entire file will be now loaded as a data frame. So if you try to look into, so if you call the describe method on the data frame object, again, df is the user-defined object, data frame object name. So I just gave it df for the data frame. And you can see here, so these are the column names, country, continent, subregion, and population, and so on. The key thing to be noted is here, of course, the country, continent, subregion are all string, and so on. But the population is also captured as a string. And it also has this comma as part of it. And I think that's the reason it's captured as a string. If the comma was not there, it would have been captured as an integer. Since the comma is there, like you have a text, you have comma. So Julia captures that column as a string. Similarly, population 2019 is captured as a string as well. And the change percentage, and because of the percentage symbol, again, I think that column is captured as a string as well. The decimal value alone, if it was stored, the decimal symbol alone, if it was there, it would have been captured as a float. But it has this percentage symbol, so that's why it's captured as a float, as a string. So let's see how to handle this data frame. Now, again, the end row column and end call, so end row method and end call method called on this data frame object would return the number of rows and columns on this in this data frame, and that I'm storing as num rows and num calls, and I can print it out. So that's being printed as num rows is 233, num calls is 6. Okay, so if you want to print the column names, you can call the property names method on and pass the data frame object, and that will get the column names, and you can print them as well. Now, if you notice in the CSV file itself, the column names are kind of little longer, as well as have more than one word in them. So we may want to rename the column names. So this is how we could do that. So we could come up with a vector of column names we want to have. Country, continent, just region, and then population underscore 2018, population underscore 2019, and then the change. So we already saw how to rename the columns of a data frame using a rename function, and you include exclamation mark to enforce that on the data frame you're calling, and then pass the new column names as the second argument. So that will rename this data frame columns. So now, also, the change column is not really needed for now. We will compute the change values at sub-data frame levels later in this code. So, so this will also help us to see how to delete a column. So the delete at method is a method that can be used to delete a particular column. And again, you're enforcing it on, and again, I'm deleting it only at the vector level, and then we'll force it on the data frame. Let's see how I do that. So delete at exclamation on this vector, new column names, which has this 6 column names. So I pass 6 itself as the second argument to indicate the column that I would really want to delete, the column index I want to delete. So this is basically a vector now. So I want to delete basically the element at a particular index in the vector. That's all it does. It's not, it has, this particular statement has nothing to do with the data frame. The new call names is just a vector, and I'm calling the delete at method to delete a particular index in that vector, that is index 6. So you can use this method to also delete an element at any particular index in a vector that you may have. Okay. So once I do that, so the new call names will have only 5 entries: country, content, region, population 2018, population 2019, not the change string. So I call the select method now on this data frame df, and I could individually pass like using before we used to colon, the column names and so on. But here I just pass new call names. So this is another syntax for the select method, where if you know all the columns you want to retrieve, you can just pass those column names as a vector. And so it's retrieving all those column rows corresponding to those column names, and I am assigning back to the DF itself. So this is overwriting the data frame with the retrieved columns only, which will be those 5 columns, not the change column. So that's how you kind of virtually delete this change column from this data frame. Okay. Now, similar to what we had done earlier, we want to add a new column, let's say the IDs column, as the first column in our data frame. So what we'll do is we'll first create a vector of IDs from 1 to the number rows, which is 233, using the collect method. And then you can again call the, so now you see, similar to what we have done earlier, I say df.ids. So even though the IDs column is not there until now, when you say df.ids, a new column is going to be created in the data frame at the end of the data frame as the last column. And the values will be 1 to 233 because you're assigning to a vector of this 1 to number rows. Now, using again the select method, you could specify in what order of the columns you want to see the result of the select method. So we pass the data frame object name, comma, and then column IDs as the first column I want to see, and then followed by a column will be the rest of the columns in the order they are already there. So that means if you now print it, it's going to print all the 233 rows with the IDs as the first column, followed by the country, continent, region, population 2018 and 2019. Okay. Now, so if you want to just retrieve the countries in the world, then you can call df.country. That's because the country is our new column name, and that will return all the countries as a vector. So I'm storing that in this world countries. And if you want to just know the number of countries in the world, you can call the length of the world countries. That will be the 233 as well, because each row, I believe, is a country. Okay, so let's just, these are the list of all the countries out there. Similarly, you can do it on the regions. That'll be more interesting. We want to know how many regions are there in the world. So you can call the df.region. And unlike countries, which we know is going to be unique values, one for each row, we know that there will be a lot of overlapping. It means several rows will have the same region, which means we want to just know the unique region names. So we can call the unique method on this vector of region names, and that will return the just unique region names as world regions. You can store as a vector, and if you want to print the name regions itself as well as length, this is how it is. So there are 22 regions overall. And then using, okay, this is important to know. Okay, so now we'll get into the task of converting the population columns to integer. We can even make it float because very huge numbers, so I can make it like in millions. So if you look at the column values here, they're very huge numbers. So we can divide, say, by 10 to the power 6 to make it like at the million level, because 1 million is 1 followed by 6 zeros. Okay. So first, in order to do the division, convert to millions, you have to first convert a string to an integer. And that's what I do with these two statements. One statement for each population column. Okay, so if you look at this column, this statement, what I'm doing is, we know that this population underscore 2018 column has this comma. So there is a replace method available in Julia, and its syntax is this. So we won't again do it on each row, so that's why I have the dot operator. So you put the dot operator in after the replace function name, and then inside the parenthesis, the syntax is this. You want to pass the column name, okay? And the second argument is like this. Whatever is the string as part of that column values, you want it to be replaced. That's what this implies is indicating with whatever you want it to be. So here we want it to be kind of basically removed. So you pass an empty or a string with no character in it as the replacing string. So basically the comma will be removed wherever it occurs in that number, that string. So you're enforcing it on all the rows in the population column. So you're putting dot equal to. So same thing, do it for the 2019 as well. Same thing, make sure you do it 2019 when you copy and paste. And then the same comma is replaced with this empty string. Now, so once you do this, that the two population columns will be still string. They're not yet integers. We are just gotten rid of these commas. So what we have to do now is we have to first convert them to an integer and then divide by 1 million to get the numbers in population numbers in millions. So this is a parse method in Julia, which you have seen earlier while getting inputs. So there are two arguments for parse method. The first argument is the data type to which you want to convert it to. And the second is the kind of like either a string or a vector, depending on what you want to pass. So here you want to pass this column vector of population underscore 2018, and you want all the entries in that column to be converted to integer values. So again, all the rows across all the rows in that particular column. So use the dot operator to apply this processing for all the rows. That's kind of like what's called the broadcast operator applied on all the rows. So the parse dot operator applies this operation on all the rows for this column. And once you do this thing, it's going to be converted as an integer. And then what I do is I can divide that integer again for each row. That's why you say dot slash for the division by 1 million, which is 1 followed by 6 zeros. So the result of that could be some before the decimal some numbers and dot some long list of numbers. So you want to kind of truncate to just say 2 digits. So you can also do that by using the round thing. So round dot. So basically, this is the division of the integer by 1 million. That's the first argument of the round function. And the second argument of the round function is to convert, restrict the number of digits. So you're restricting the number of digits to 2 digits after the decimal point. Okay. So if I want to just do it stepwise and combining 2, 3 things into one statement, that's how typically it's done. So first you are passing each row and of any column like this. So that's converting the column values in each row to an integer. And then you are dividing this by 1 million. Okay, so that will be now in some decimals, but that will be like you could have more than 2 decimal values after the decimal point. So you want to round it. So the round takes 2 arguments. This is the first argument. And the second argument is the number of digits you want to round it to. And the round is again applied to all the rows, so you need to have this dot operator in front of it. Okay, so that's how we are doing this for both the population columns. So I'm not printing them, but if you print it out, that's how it will be. The population columns will now have in millions with just two decimal place values. So now let's say I want to extract only a subset of this data frame, DF. I want to just look at the records for the continent Asia. And remember, continent is a column name. So I can again use the dot equal to compare all the column values with Asia and retrieve only those records for which the continent value is Asia. And that those records will be now stored in this Asia underscore DF. That's the data frame name. Um, so I'm printing that out. So let's see how it gets printed out. So this is the all the records of the Asia data frame. And you see how the population values are getting printed. So this is in millions now, and just with two decimal places at the end of the decimal point. Okay. Now, we want to now use the by method to kind of do some grouping now. So I'm grouping by region. So I want to kind of create a region-based data frame where each row will be a particular region. And I want basically when you do this grouping and combining, it's basically getting some data frame that has the statistics based on the individual values of a particular column. Here, the particular column you're dealing with is a region column. So for each region, you want a count of, say, the number of countries in that region, the population, the total population across all the countries in that region in 2018, similarly in 2019. So again, like I explained in the previous video, you're creating a new data frame here at the left. That's the name of the new data frame by region. So the names, the column names to the left of this equal to sign, or the column names that you're going to give for this new data frame. And the column names on the to the right of this equal to sign, or the column names that are there in this underlying DF data frame, from which you want to extract the region-based data. So you could call, if you want to find the number of countries out there, grouping by regions, for each region, how many countries are there. So the length of the column country, the column name will get you the number of countries for a particular region. So that will be the value for that countries. Similarly, you can add all the population underscore 2018 data for a particular region, sum them up. That's what this does. This is a very powerful method. You're looking at just all the a particular column only for this a particular region, and then summing those the column values. Similarly for 2019. So just to differentiate between the two, the population column names, the two data frames for the sub-region by data frame, or anything extracted as a subset, or grouping wise. I am labeling them as pop underscore 2018 and pop underscore 2019, whereas the original data frame, they're like population underscore 2018 and population underscore 2019. So if I print it out, before I print it out, what I also do is once I have the population for these 2 years, now region-wise, I want to calculate the change percent. So this is how I calculate change percent. Take the difference in the two populations. So basically, you want to see whether it's an increase from 2018 to 2019 or a decrease from 2018 to 2019. So you subtract from the 2019 population in the sub-region data frame minus the 2018 population in the sub-region data frame divided by the 2018 population. So you want to see that there is an increase or decrease. And then that will be like a fraction. So you want to assign a percentage to it, so you multiply by 100. Now you want to do all these things for each row in that data frame. So that's why all these are accompanied by a dot in front of that minus, and then a dot slash to do the division. So you're taking the difference in the two populations, year populations, and applying it for all the rows in that thing, and then again dividing for each row that corresponding population 2018, and then for each row you're doing a multiplication with 100. So that will be the change percentage for each region. And again, the way we add a new column is just by calling the uh, column name on the data frame with the dot operator. So it gets added as a new column, and on the right hand side, you're assigning the values to it basically. Uh, so if we print out this subregion data frame, this is how it gets printed. So you can see there are 22 regions, and these are the region names because of grouping by region. So that itself will be the first column in the subregion data frame. The second column will be the countries, and you'll get a count of the number of countries in each of those regions. So that will be this value. And then you'll get the sum of the population across all those 8 countries reported in the original DF data frame for the particular region. That is this. Similarly, for the 2019 year. And then you want to calculate change percent. So the 2019 population minus 2018 population divided by the 2018 population, and then multiply it by 100 to get the percentage. So this is the percentage now. Um, Now you could round the change percent also to two decimal digits if you want to. I'm not doing that here. You could do that. Okay, so with this kind of overview, we can now figure out which regions in the world incurred an increase in the population percentage and the most significant increase, and which regions incurred a negative, means a decrease in the population percentage, with the decrease in the population, and which region incurred the significant decrease, and so on. Of course, the data file itself had the change country-wise, change percentage country-wise. So it's there in the file itself, but this is not there. So we are able to do that now from our analysis of this file using the data frame package in Julia. Okay, so we can notice that probably this 3 point something is the largest. So that's a positive. That means corresponding region, the Middle Africa exhibited the highest increase in the population from 2018 to 2019. And then the lowest, or even the negative, that will be the lowest. Let me see, the lowest among the positive could be interpreted. That would be, you can sort it if you want. You can sort based on the change percentage, and that would help you to figure out whether it's an increase or decrease. These two, Polynesia, Micronesia, are very small regions. So in millions, there's no difference in the population numbers. So if you look at the negative sign, it's going to be only for Eastern Europe and Southern Europe. So basically, the Europe, Eastern Southern Europe, are showing a decrease in the population from 2018 to 2019. Okay, so that kind of shows where in which part of the world there's kind of a tendency to have an increase in the population, and which part of the world has a tendency to have a decrease in the population. Okay, so let's do it now by continent, the same grouping. So here again by function, the underlying data frame. So the continent is a column name by which you want to group. And so that will be itself will be the first column in the data frame. So this is the name I come up with for the continents by DF data frame. It's up to you what name you want to use. So now I want to here list the number of regions in that continent. Again, if you look at the original CSV file, say for example, Asia, uh, the countries are unique, but the regions could be repeated under each continent. Because, for example, China, Japan, they're all in Eastern Asia. India, Pakistan, they're all in Southern Asia, and so on. So it is possible that there could be duplicate entries for the regions. When you just say um, region within a continent, within a particular continent, there will be duplicate entries. So you want to get the unique region names for that particular continent, and you want to, that will be a vector. of unique region names, and you want to just find the number of such unique region names within that continent. So you call the length method. That will get you the number of unique region names. Now, you want to get the number of countries within that continent. We know the country names are unique, so you don't need to call unique on the country column vector here. You can just get the length, and that will be the number of countries within that continent. Similarly, you add up all the population numbers for the particular continent. That will be pop underscore 2018, pop underscore 2019. And you go the same approach of finding the change percentage now at the continent level and print it out. And this is how it will show up here now. So there are only 5 continents to look at: Asia, Americas, Africa, Europe, and Oceania. So for the 5 continents, the regions, so these are the 5 regions within each continent. So all the continents have more than one region. That's good to know. Even the Oceania continent has 4 regions. So, and also all the continents have comparable number of regions. No continent has substantially more number of regions. Now, even country-wise, all the 4 continents, the main 4 continents, have comparable number of countries, which is good to know, because we may think that, for example, Asia may have more countries compared to Americas and so on. So Americas includes North America, South America, and even probably Central America. It's a region like that. So 53 countries there. Europe little lower, 48 countries and so on. Oceania has 23 countries. I think Australia, New Zealand come under that group. Okay. So these are the population numbers in millions in 2018 and 2019 and the change percentage. And all the 5 continents report positive increase in population from 2018 to 2019. But if you look at the largest increase in the population among the 5 continents, the Africa continent reports or kind of is observed to have the largest increase in percentage. And that's reflected here as well. Region-wise, we observe the Middle Africa to have the largest increase in the population. And the lowest increase is again among all these 5 numbers, 0.1, which is the Europe continent. And we observed it to be reflected here as well. The negative numbers are reflected region-wise for Eastern Europe and Southern Europe. So that's a good kind of correlation when you look at the region level and the continent level as well. And the last way to kind of group is like, this is what I said, you can group by more than one column here. So you can pass the continent, that's the first level. And then within each continent, you want to group by region. So the continent and region will automatically be listed as columns. And now you just want to have an estimate of the countries within that region of that particular continent, and then the sum of the populations within that region of the particular continent. So if you print it out, this is how it looks like. So Asia, we know, has 5 regions. So these are the 5 regions within Asia. So this overview is not possible. It is possible here, as you can see. It has 8 countries and the same thing. Yeah. So it's the same thing that we are having here, but the only thing is this doesn't display the continents because we are doing a region-wise data frame. And so we are avoiding the continent's name. So if you want to again have it in the order in which the continent names are displayed in the data frames, like Asia first, followed by Americas. If you look at this, Asia, and then Americas, and then Europe, and then Africa. So that's the order in which you're extracting the continent names. So it's good to have a view like this as well, where you have the continent names explicitly listed. And so it's basically a region-wise data frame, where one column just displays a continent as multiple values. Okay. So again, the sorting is what is more also need to be looked at. So when you're doing this grouping thing, the column values for that particular column that you're looking at. So for example, even here, let's look at, so you already saw continent, the order in which the continent names are listed, but looking at the region wise, Eastern Asia, Southern Asia, Northern America. So let's go back and look. These will be the first three region names that will be considered in the region-wise data frame. Okay, so in the region-wise data frame, because this is the order in which the names are appearing, Eastern Asia, Southern Asia, Northern America, Southeastern Asia, and again Southern Asia, so that will be combined with this. And then after Southeast Asia, the new column name value that will be seen is South America, that's listed, and then Western Africa, and then Southern Asia is already seen. So next will be Eastern Europe, and then Central America. Eastern Asia is already seen, so new thing is Eastern Africa, and so on. So again, that's how the extraction is done in the order in which the column values are appearing in that data frame. So, but this way, so this is a mix of regions. So you have some regions in Asia, and this is the region America, this is the region Africa, and so on. So you have a mix. So in order to have kind of some level of uniformity, grouping by continents and then by region like this will have all the regions in Asia first, all the regions in Americas. So each continent-wise grouping, and then the grouping by region-wise as well. Okay. So with this, I'll stop this video.